started. Good morning and welcome. My name is Steve Gordon. I'm the Outreach Chair of the SIG HPC Education Chapter. And this morning we have the pleasure of having Felix Antoine Fortin tell us about a new tool for teaching using HPC called Magic Castle. So Felix, I will turn it over to you.
Hi, thank you, Gordon. I'm gonna just share my screen. Should be good to go. So as Gordon said, I'm Felix Antoine Fortin. I'm from Quebec City. I'm the principal developer of Magic Castle, and I work at Université Laval in Quebec City. I'm part of a regional partner of Digital Research Alliance of Canada, which is called Calco Quebec, which offers HPC and ARC services to institutions and researchers, mainly from Quebec, but also from the entire Canada, and all of this for free using government money. So today we're going to see essentially 4 parts to this webinar called Terraforming the Cloud to Teach HPC. So one might wonder why cloud to teach HPC, why not using our HPC systems or something else. We're gonna get an overview of existing HPC in the cloud tools. This is not an entirely new idea. That field has been explored before, so we're going to see why we would propose in other tools. And then I'm going to introduce you to Magic Castle, and we're going to see different use cases of Magic Castle that has been used in a while once I've released the Kraken that is Magic Castle. So why cloud to teach HPC? I tend to see it as a 2-scale problem. The first reason would be on the macro scale. So if we take a look at how does it work for advanced research computing in Canada, we currently have 4 regional partners that exchange and try to work together to teach their users how to use HPC, but these partners also provide access to their own data centers. So there are similarities, there are specificities to the different data centers, but all of these groups that are part of the Digital Research Alliance of Canada are trying to work together to provide workshops and training across Canada on the various data centers. So someone from Quebec could actually use an HPC system from BC and could eventually be taught HPC on that system. What it means is on the national level, the Digital Research Alliance of Canada is actually teaching over 150 workshops, tutorials, hands-on exercise that require some form of HPC system a year. And on the other hand, all of our systems, as it's the same across the world, our HPC system are up to a 95% usage just for research. So if we're trying to actually teach our people HPC, how can we do it without actually entering and impacting the actual research that is being done on our HPC systems? So that's our macro scale questions. How can we actually teach large classes, a high number of workshops on our HPC systems without impacting research? Now, on a micro scale, on an individual level, we have the Digital Research Alliance of Canada and 2 regional partners have over 200 research support staff from various backgrounds, whether it is bioinformatics, engineering, but we have less and less sysadmin by trade. People have high scientific background that are of use to support our researchers, but they know less and less about sysadmin and about systems. But still, learning about the systems is an important aspect of their work at some point. But while in the past we could have them work with a few gray boxes, we are no longer able to do that. And so how can we actually provide them a tool that by themselves they'll be able to learn about system administration, about how our HP systems are built, and eventually maybe develop tools to help user exploit those infrastructures. So how can we, on an individual level, how can we propose a tool that will help them better offer and better support the actual researchers that are using our system? Which bring us to a philosophical question, which is a bit left field, I would say, but I like to entertain the idea of asking my audience, why do you think there are more wizards in Harry Potter than in Lords of the Rings? So if you are familiar with both, if you're not familiar, in Harry Potter, there are a lot of wizards, whole wizards world. While in Lords of the Rings, you can count up to maybe 4 or 5 very powerful sorcerers. If you want to drop in the chat maybe an answer, or if you want to raise your hand and just claim to know the answer, I'll give you a few seconds. Yeah, in the chat. There's Andrew Reed. Yeah, there's a school in Harry Potter. Fewer barrier to entry in Harry Potter. Andrew, you're on a mark. There are wizardry schools in Harry Potter. Now they are actually sharing their knowledge. They are teaching you how to be wizards. Now you might say, well, how does it? Where are you going with this, Felix? What's the link with HPC? Well, on the left side, if you might have not seen, but in this picture, I'm in front of our data center in Université Laval. It's a big tower of cement, of concrete. This is a classical traditional data center, a big piece like Sauron Tower. Like this used to be accessible to a few experts. Now we're trying to move out of that to a Hogwarts wizardry school, but not only Hogwarts wizardry school, we want that to be made of Legos. We would like people to be able to play with that school and replicate it as they want. So we want to be able to do on-demand infrastructures and ideally, at least for teaching, move out of the traditional monolithic data center access. So we want an accessible, inexpensive sandbox environment designed to facilitate teaching and experimentation. And why cloud does it? How does cloud actually help us doing that? Well, on a macro level, it gives us a controlled, replicable teaching environments to audience of variable size. Like cloud provides you resource on demand and it scales. If you have a large audience, you could create a very big Hogwarts school just for your class. On the other hand, if you're just an individual who would like to learn about HPC by building small castles, small Legos, you can do it on your own for very few resources. You don't have to you don't have to buy hardware. You don't have to. You just have to create an account, enter your credit card, or maybe just beg for a few credit from your favorite cloud provider, and then just start playing, start learning. This is what cloud is providing. So cloud can actually provide a building blocks for both scale, both macros and micros. So what are the existing tools? So before I came up with the idea of Magic Castle, the field has been explored by others, and some are cloud specific. So all the cloud providers have actually detected that, yeah, actual HPC user might be interested in using their cloud for scaling up without having to actually buy their own data centers because they have physical or they don't want to manage hardware. So Microsoft, AWS, Google all came up with their own what they call HPC toolkit or whatever their own trademark for it. Now, this is cloud specific. As the Digital Research Alliance and their partners, we are independent parties. We don't swear allegiance to a specific cloud. So cloud specific tools were not kind of the right solution for us. On the other hand, you have a few academics that actually thought, well, we want to do multi-cloud. We would like to do multi-cloud environment. And I found two of these projects. One is named Cluster in the Cloud. The other is called Elastic Cluster. Both of these were developed in Europe. Unfortunately for us, Cluster in the Cloud, which is the most recent, was not supporting OpenStack, and the Digital Alliance research partners actually are hosting their own cloud, their own community cloud as OpenStack. So OpenStack had to be a first-class citizen in the tool of our choice. Elastic Cluster did offer it, but it was not quite what we were looking for. All these tools have different recipes to come up with the same idea, but most of them actually did start with programming their own command line interface. So you have to, as a user, in order to interact with that tool, you have to get on the command line, start typing commands, and at some point you get something like that looks like an HPC cluster. It all comes up with a different schedule and stuff. So we took that in, and to be fairly honest, that review of tools came up a bit after, right? I'm a developer by trade. The first thing I did was starting my own prototype, not reviewing literature. I came up with some excuse on why that tools is the right one after actually developing it. So let's be honest, but I think it's a great tool. So why proposing another tool? So we wanted an open source multi-cloud solution that included OpenStack as a first-class citizen. This is what we wanted to do at first when we started developing Magic Castle. It was mainly for OpenStack. Then we broadened our scope. We wanted Puppet to be the configuration management. Now that might get people cringy. Some people don't like Puppet, but internally, and most of the Digital Research Alliance partners are Puppet shop. So I wanted to be able to reuse some of the configuration code that was used on our HPC system in the cloud. And ideally, all cloud interaction would have to be done by third-party tools. I didn't want to go out, look at the GCP, then the AWS, then Azure direct API to create resources and create my own command line. I've done that in the past. I'm out of the building my own command line interface business. This is I'm leaving that to other people. So we came up with a few principles out of these problems. So we wanted to focus on recreating the HPC environment. We wanted to be able to provide an experience for beginners with minimal prior HPC knowledge. We wanted to be able to include key HPC features, job scheduling, data transfer, GPU, parallel distributed computation. All this without actually having any knowledge or very minimal knowledge of cloud. The only thing that you need to know is how to create an account on cloud and for a minimal cost. And ideally, it should take just a few minutes to set up a sandbox and a few minutes to destroy it. So then it costs you almost nothing to build your cluster. Which brings us to Magic Castle, an open source infrastructure as code aiming to reproduce the HPC user experience in the cloud. So based on what I've just shown, based on our requirements, what we did for infrastructure is we went 100% with Terraform. And I'm going to cover what is Terraform if you're not familiar. So it means no CLI, no wrapper, no API interaction. From our part, all of that is actually being done by Terraform. And it also means there's a single interface to interact with all major cloud providers. That is a single Terraform file. The configuration is being done by Cloud Init and Puppet. No knowledge of Puppet is actually required. Puppet is essentially acting as a virtual sysadmin of some sort. So it's not very intelligent. It's not ChatGPT, but it can fix a few error if a beginner actually starts manipulating configuration file. After an half an hour, Puppet comes behind and just clean the mess, and the HPC cluster can come back alive. As for scheduler, we went with Slurm. We wanted an open source solution. There's less and less these days. Slurm, but also Slurm is currently the main scheduler we are using across Canada with the Alliance partners. And we came up with, based on that solution and based on the tools we've selected, we were able to actually offer support for 5 different clouds. So AWS, Azure, Google Cloud, OpenStack, and OVH, which is a French provider of cloud, which has all of his infrastructure and all of his cloud solution actually based on OpenStack. So OVH was just a freebie when we developed Magic Castle for OpenStack. All of this is actually being designed so that if a new provider came up, or we wanted, for example, Magic Castle for Alibaba Cloud, it could be done in afternoon, following the documentation we built. So it's a pretty clean design. So Magic Castle, actually what it does, it spawn the instances, create volumes, create DNS records, bootstrap passwords, scale compute, customize, and all this is customizable via parameters and YAML file. It does the whole thing just in a single file. It's a curated solution. It made some decision for you, but all of these the decision can be modified afterward via configuration file when you are becoming an expert. But as a beginner, you just have to modify a few parameters. So what we're planning to build is this big graphical mess of services that are interconnected, that is an HPC cluster. So you have login node, you have compute nodes that are interacting with a management node, and all of these services are separated on different virtual machines that you can name as you like. You can name your cluster as you like. You can move the services around if you like. But as a beginner, when you get a Magic Castle Reese, this is what you get. So this is what we're planning. We're going to apply it with Terraform, and then the configuration is being done automatically by Puppet, and it's configuring you a whole suite of services like FreeIPA, Slurm, console, AppTainer. It configures the GPU driver based on the material that is being detected, etc., etc. But not only that, but if you were here last year when one of my colleagues and collaborators on Magic Castle, Anon Case, presented, when you install Magic Castle, you also get over 300 scientific software, because when you actually spawn Magic Castle cluster, we are also installing one of the 2 CVMFS stacks. So we are not downloading 300,000 software directly on your cluster, but we are making them available based on your stack of choice using CVMFS. If you're not familiar with it, I encourage you to go look at Helen webinar from last year, but it's a very interesting technology, and it provides, so out of the box, the cluster comes up with thousands of software ready to use, just a module load away. If you are more on the SPAC philosophy side, you can also use SPAC on Magic Castle without an issue. You can just say, I don't want any software stack being installed in my cluster. I'm just going to install and compile my software using SPAC. So all of this has been a successful experience so far. We have over 1,000 workshops that has been successfully used Magic Castle to teach We also have graduate university courses that are using a Magic Castle cluster for the whole semester, and they have graduate actually log in and learn about HPC or specific field that require HPC using Magic Castle. And this has been originally released open source in 2008. So we will be celebrating our 6th year of development this year. Now you're convinced this is magic. How does it actually work? There's no one involved. There's no actual magic involved. It's just APIs and Terraform. Is there a question?
No, go ahead.
Right. You've heard the word since the beginning. So what is Terraform? So Terraform is actually an infrastructure as code software tool. What is infrastructure as code? It's actually you are writing text file that describe what your infrastructure will look like. Then using Terraform, the command line tool, you apply those resources, and Terraform actually talks with the cloud provider API to create those resources. So you describe your infrastructure using code, and Terraform translate that code into API calls that eventually materialize as virtual cloud resources. So this is the workflow. So as a practitioner, you write code in your favorite text editor. Then the purple boxes are actually command line calls. And then the command line actually talks with your cloud provider. Then, as I said, it materializes into virtual resources. So what does this code actually look like? So it's a description of the resources. So in this case, we would want to actually build a virtual machines in OpenStack. So we're going to call it a resource, and the name of the resource, then the different parameters of that resource. Now, you might say, well, I'm not familiar with it. I don't want to start writing all these virtual machines for my cluster. I'm just a beginner. Now, the beauty of Terraform is all these resources can actually be hidden behind a module. So as the developer of a module of Terraform, you can provide just a few variables, a few parameters that will then be used to define a much larger amount of resources. So the beginner can just use a module while the expert can actually define different resources specifically. So what we do as a Magic Castle developer, when we actually release a version of a Terraform modules that can be modified via different variables that are quite easy to understand for the beginner. And we actually provide some very sensible, some well-curated values for these variables at the very beginning, which means that as a beginner, when you are trying to use Magic Castle, the main thing that you have to do is select a name for your cluster. So as I said, you have written your code, then you're going to call Terraform plan and Terraform apply, and then Terraform, what it's going to do is using your cloud credentials, going to talk with a cloud provider API and create your virtual resources. So how useful is that if you're not convinced from my previous spiel, is that Terraform actually supports a number of cloud infrastructure. And how they do it, the actually being able to do it is that the actual cloud providers saw the value in Terraform and started building their own plugins. So it's the AWS and Google Cloud and Azure staff that are actually providing the plugins for Terraform to interact with the API, which make it always up to date and very easy to use. So combined with its ability to build infrastructure using highly level building blocks, Terraform is an excellent choice for building complex environments like HPC clusters in the cloud. So it made perfect sense for us to choose Terraform instead of, so the alternative would have been to actually write Python code or write whatever kind of programming language to interact directly with the cloud provider API. And all of these APIs are different, and they all work differently. While with Terraform, you get to get a virtual machines, you have to just write a resource from a different cloud providers. There are different parameters, but with Magic Castle, we were able to wrap that into a single interface. So it's easy to install Terraform. You just download it. It's a single Go binary that you can install on your machine. So Magic Castle is infrastructure as code that's being interpreted by Terraform. So the infrastructure of Magic Castle is actually defined in a main Terraform module. Each provider has its dedicated main module, but all modules actually share common inputs and outputs. So it means that when you select a cloud, you are no longer locked in order to interact with different cloud providers. You are going to actually select the same parameter and just modify a few of these things. Each main module actually use three common sub-modules that we're going to see. The first main module is the design sub-modules that actually transform the inputs from the user into a data structures that is going to be used internally to generate the resources specific to each provider. So, for example, the user is telling us, I want 10 compute nodes. When this is then written in a data structure, and that data structure is then interpreted by the Magic Castle code to create the right resources, whether the user actually selected Google Cloud, OpenStack, or AWS. So it's completely transparent for the user, but internally we have mechanics to determine which resources, which parameters are going to be used. Then just creating the actual virtual resources is not enough. We have to configure it. So the configuration sub-module, which is also coming out across all providers, actually create a cloud config file. So it's just a file that is being inserted in when we boot the virtual machines at the very beginning. And that what it's going to do is actually configure the SSH access so Terraform can log into the machines afterward, but mainly bootstraps Puppet. So we are bootstrapping a whole Puppet infrastructure just using that file. That YAML file actually looks like that. So it's pretty standard across all cloud providers to allow you to run a few commands on first boot, install packages and stuff. And what we do is using that file, we actually bootstrap a Puppet infrastructure. Then we have the provision submodule. So just the information that we can put in the YAML file that is being inserted in the virtual machines is not quite enough, and it's only valid for the initial boot. So if we want to keep our virtual machines updated on some information about Terraform and about the state of our infrastructure, we actually use the provision submodules that upload on our Puppet server another YAML file that describe the old infrastructures in terms of like how many GPUs, how many CPUs, what are the instances and stuff, and it looks like that. So the host keys, all of that is actually described in a separate YAML files that can be updated during the lifetime of our cluster. So at any point in time, we can actually increase, decrease any of our type of nodes at any point in time, and that YAML file is actually going to be updated. While if we were to do it in the previous cloud config file, that file is only being written once at the beginning of the booting of our virtual machines, which means we were not able to put that information in there. So that YAML file is being updated each time there's a Terraform apply, which is quite convenient. So this set of common submodule create an easy to use interface without vendor lock-in. So how does it look like? So this is how you would describe and create a Magic Castle cluster in AWS. So your source of code is the module AWS. The config get URL is actually the URL pointing to the Puppet config file that is being developed for Magic Castle. This could be replaced at some point by a different environment if you were a Puppet guru or you had your own intention of building your own environments, or you would like to fork that actual environment. Then the config version, so you can use different version of Magic Castle as we release them. As I said, as a beginner, your main question will be, how do you name your cluster? This will be your main question. Then it will be then you could have be set. You wouldn't have to ask more question about the actual content of that main file. You could change the name, save and quit, then Terraform apply, and you would get your own cluster personalized for your need. Your domain, so if you actually own a specific domain, Magic Castle can actually create the DNS record using your DNS provider API key, and which is quite convenient when giving out workshops. In the past, we've done workshops where we were providing IP addresses, and this was a nightmare. So creating DNS record and a specific name for our cluster for our workshops works wonderfully. So Magic Castle does all of that, including SSL certificates. All that is being handled by Magic Castle. The image, so this I've not covered that aspect, but Magic Castle essentially runs on CentOS, Red Hat kind of breed of operating system, which means Rocky, Alma Linux, 7, 8, and 9s are supported. We do not currently provide an environments for any Debian operating system. So then your actual infrastructure, what you're going to deploy in terms of computing resources, is described in the instance input. So in this case, we have 3 different type of instances: a management instance, a login node instances, and compute nodes. And then the count numbers is how many of these types we're going to get. So 1 login node, 1 management node, and 50 compute nodes. And as I said, those counts could be modified at any point in time. And then we're going to describe the actual file system that we're going to use. In this case, it's a NFS file system with 3 separate volumes that are being shared from the management node to the different instances. Now I've just changed providers. Just by switching the next slide, I've moved from AWS to GCP, and it's the same, or almost. Like, if you look closely, what has changed is the actual image name, which is cloud specific, and the instance type. So all cloud providers came up with their different name for the same kind of instance, which defines how many CPUs, how many GPUs, and how much RAM you're going to get for your virtual machines. This is cloud specific, so we had to deal with that, but otherwise, it's the same interface. So if you have described your AWS cluster and now you no longer have AWS credit and you want to move in Google Cloud, you could get the almost same cluster just by changing provider and making sure that the instance type correspond to your previous cluster. Easy as that. Now, the actual role of your instance is not being defined by the host name. So in this case, we have named our management node management, our login node login, our node nodes, because we're not that imaginative, but we could have named it XYZ. But what the actual role of our instances is defined by is the tags. So our management node is being installed and being configured for different services based on the tag on the left, the tag on the right, sorry. So this is not very important for a beginner, but it means that we can create all sorts of environments by just defining new tags with different services under those tags, or moving the tags around which also mean that the smallest cluster that you can get with Magic Castle is actually a single virtual machines with all of these tags combined. Or you can create a very vast infrastructure where you actually dispatch the management, the login, and the proxy and all that stuff around the different instances. So currently the Puppet server is on the management node, but we could move that tag into a separate instance and have it would cost a bit more, but it would mean that all of our instances are actually having a separate role. So that so the Puppet information is so the Puppet the information from Terraform, the description of our infrastructure is being done normally in what is called HashiCorp language, so HCL. That translation into Puppet doesn't talk HCL, doesn't know about our Terraform state. So in order to inform of Puppet of what's the global status of what's the global state of our cluster, we actually have Terraform upload on the Puppet server a YAML file with a description of our the whole infrastructure, which is Terraform data, which is being uploaded by the provision submodule. And then once the infrastructure is created, Puppet actually manages the configuration without any inputs from the user. So the Puppet server tells the management node, the login node, the node, in the different node, what are they going to do, what they need to install, how they need to be configured. While all of this is being done automatically as an end user of Magic Castle, you can still modify or provide more information on what you would like, on how you would like it to be configured, which means you can define, for example, specific LDAP user that you would like to be added to the database. You can actually, as we are running fail to ban on the login nodes, you can add on to a whitelist a list of or a list of IPs that you want to be ignored, so people are not being banned from failing to enter their passwords, which happens during workshop with beginners. So there are over 40 classes that can be modified and hundreds of parameters that you can modify once you get to be an expert, or once you get more accustomed to what is Magic Castle and how you would like to modify it to fit your need. But as a beginner, you can completely ignore that and still get a functional HPC cluster with all of the bells and whistle by just applying the previous HCL code that I've shown in the previous slide. So just using the previous HCL, what you get, as I said, is this model of virtual machines and network and firewalls, routers, all of this accessible from the internet as an end user, as a guest user. So yes, you have an admin account, but you can also open guest accounts with a common password, which is very convenient when giving out workshop and teaching about HPC. Now scaling and all scaling. So when I started talking about Magic Castle in 2018, people started asking questions about, well, you have this cluster, but if we get a lot of jobs submitted on it, could it auto scale? Could it increase? It's the cloud, right? It's infinite scale, infinite resources. We would like to tap in those infinite resources using Magic Castle. So I started working on my first answer was, sure, just go into your main.tf and modify those numbers and reapply. And they were like, yeah, we're not going to look at the job queue, Felix, and update those numbers every hour to just scale our cluster. We would like that to be automatic. And so I came up with the idea of auto scaling by just applying a tag. So it took me 3 or 4 years to actually come up with the right idea, because as I said, as an initial design point, I wanted to make sure to never have to interact with a cloud provider API myself. That came up being problematic, because if you if you're familiar with Slurm, all of the mechanics to auto scale in the cloud in Slurm is there. But the Slurm example, what they do provide is, well, just write your own tool in your favorite language of choice, and that tool should talk directly with the cloud API. So in order for me to actually support 4 or 5 different cloud providers, I would have to write my own programming language. So let's say Python code to interact with the different cloud providers directly via Slurm. So the Slurm agent node would call for example, the GCP API using my own Python program. And I didn't want to do that. I just wanted to write Terraform. I just wanted to talk with a single API. But Terraform was a CLI tool. And then eventually appeared what is called Terraform Cloud. So I presented you the Terraform CLI so you can run and apply Magic Castle on your own computer. And then the Terraform CLI talks with the cloud provider API. The peoples from HashiCorp came up with a service where that command line tools actually runs in the cloud, and it also has an API. So it means that Magic Castle no longer has to talk with a specific cloud provider API to suspend or resume instances. All it has to do is talk with the Terraform Cloud API. So how do we do it? So when a user actually submitted jobs to Slurm, the Slurm control node or the Slurm control manager actually determines whether there's enough computing resources available. If not, it talks with our own small Python programs, which is 100 lines, and then tells it, well, I need nodes XYZ to be resumed. Our program actually first tells Terraform Cloud, please add to this list of host names this host name. That actual modification means a new plan in Terraform. So the actual previous Terraform plan, our whole infrastructure is being modified because we have modified a variable from our main interface that is common to all of our cloud providers. Based on the new value of that input, we just apply our Terraform plan. Terraform now talks with any of the cloud providers with the cloud provider that we have selected. So just by modifying a single variable, we can actually talk and auto scale with any cloud provider. So Terraform Cloud talks with a cloud provider, tells it, well, create me a virtual machine with that new name that we have added to the pool. And at some point, the virtual machine boots, join Puppet, resume, then report back to the Slurm controller saying, hey, I'm now ready to get jobs. And voila, we have auto scaling. And the same can be done using for suspending resources. So if you have actually nodes that are sitting idle, those are being automatically found out by the Slurm controller, which asks the Magic Castle autoscaler to turn it down. We just modify a single variable inside of Terraform Cloud, reapply the plan, and those virtual machines are suspended and deleted, which means they are no longer representing costs for your workload. So Terraform Cloud is actually managing Terraform runs in a consistent and reproducible environment. It has a free tier that allow you to manage up to 500 resources, and a typical Magic Castle cluster consume around 60 to 70 resources. So you just using a Terraform Cloud free tier account, you can manage up to 5 or 6 Magic Castle cluster with auto scaling without an issue. And then Terraform Cloud has actually different paying plans where you pay by the resources and by the hour. That said, Terraform Cloud is not unique. There are other services that offer an equivalent of Terraform Cloud with an API. Currently, with Magic Castle, we haven't developed autoscaler for those different services, but it would be possible to at some point. As I said, for in terms of autoscaling, it's quite simple. In order to do autoscaling, your Magic Castle code has to be in a Git repository, in which you're going to define a if you value that are specific to Terraform Cloud, you link that repo with Terraform Cloud, configure that variable that I said, that pool variables that going to contains the hostname that needs to be suspended and resume. And then you launch the execution in Terraform Cloud, and then your cluster is being able to resume auto scale based on the amount of resources that is required. The actual maximum amount of virtual machines that can your cluster expand to is defined in your main.tf. So if you want to say, well, at most I want 10 nodes, this is what the count is for. So when you define the pool tag, none of the virtual machines are going to be created for that type of instances. They're just going to be created by Slurm via the autoscaler. So the autoscaling logic is cloud agnostic. It is expressed in around 100 lines of Python, so it's quite convenient for us to actually manage and keep updated. And that API tokens also only requires 2 permission to modify variables and create a plan. And that would have been the other downside of actually having the Slurm controller contact directly the cloud provider. It would have mean that on our Magic Castle cluster, we would have to put the API, the token or the API key to talk with your cloud provider directly. So while we try to keep Magic Castle as secure as possible, we were not comfortable with asking people to actually put their cloud provider credentials directly on Magic Castle, because those are highly seeked for. You have people actually looking for these keys with bad intent in different Git repos and stuff, because they are looking to spawn virtual machines using your credit cards to do either Bitcoin mining or spamming and stuff. So we try to reduce the surface area of potential problems as low as possible by just providing the token key to a single cloud provider, which is Terraform, which can do very little, just modify your variables and create a plan, and that's it. The compute nodes can be heterogeneous. So you could create a cluster with GPUs, with x86, even ARM64. We have a partner that is using Magic Castle to have a cluster with all these types of instances. And based on what you require in your job in Slurm, it can auto scale to the right type of instance. So finally, we're going to cover a few Magic Castle use cases. So once I've released Magic Castle, people started using it for things that we're not necessarily teaching, or teaching why quite broadly. So my employer and digital partner of the regional partner of the Digital Research Alliance of Canada is actually Magic Castle, using Magic Castle to teach all of their classes, workshops, and spring school solely using Magic Castle. So we are no longer using HPC cluster to teach about HPC. All of that are being done in Magic Castle, which also mean that they came up with their own recipe for the different courses, and they are teaching all sort of stuff from the Unix command line to OpenRefine to MPI to GPUs computing. All that can be done with Magic Castle. And then once we started doing workshops, professors at different universities started to raise their hands saying, well, I would like my own cluster for my course. So we just all of the, I think these 6 clusters are just for the current winter semester. So they have separate clusters. The different students uh, don't interact with each other. They just share a single cluster for their labs and their teaching needs. And then at the end of the semester, when we no longer need it, we just destroy it. And all these clusters are also being configured with auto scaling, which means that most of the time outside of the lab, they are just using a very few resources for management and logins. Uh, as I said, one of the last year, Alan was here to present Easy, and Easy is actually now using Magic Castle as a build infrastructure for their own software. So what they do is, in order to get software at some point into CVMFS, they have people submitting PRs on GitHub, and those building the building of the software that is being proposed via PR is actually being done by a Slurm cluster, and that Slurm cluster is actually Magic Castle. So based on the actual requirements of the compilation job, Magic Castle with auto scaling spawn a virtual machines with the requirements. So for Easy, for example, they do actually build for different infrastructure. So all that means it spawns a series of job in Slurm. Slurm resume the right instance to compile that software, and then the artifact are being saved eventually on CVMFS, and then they can be loaded back in a different Magic Castle cluster if someone would like to use that scientific software. And finally, if you're in the US, you might be familiar with Jetstream 2. So last fall, someone from Jetstream 2 actually took Magic Castle, and since it was all Terraform, it's been they have integrated as a template in Cacao, which means while if you're not familiar with the command line or you're not familiar at all with Terraform, but you have a Jetstream 2 account, you can log into Jetstream 2, and using the web UI, you can spawn a Magic Castle cluster using the web UI provided by Jetstream 2 and Cacao. So because of our design, because of our choices of tools with Terraform, we were fully compatible with a separate project, which was Cacao, which at the very beginning we didn't talk with each other, but at some point we met up and we said, well, we can just, yeah, sure, we can just integrate it into Cacao and have the web interface actually fill your famous main.tf for you, instead of having people actually using command line to spawn into a Jetstream. So an interesting point, which means if you have a Jetstream 2 account and you're not even familiar with Terraform, just today you can give it a shot at Magic Castle by just logging into Jetstream 2 and spawning your own Magic Castle cluster. So to finish, Magic Castle, it's simple to use. It can auto scale your infrastructure, and I might be biased, but I see it as the ideal software environment to teach and learn about HPC. And it's actually cloud agnostic and open source. So you can find it on GitHub at Compute Canada/Magic Castle, and I'll be open for questions.
Well, thank you very much, Felix. Excuse me. Other questions? You can either put something in the chat window or unmute and ask your questions now. Have them. Someone wanted the slides. Will you be able to send me the slides so I can?
Yeah, sure. Would you, Gordon, would you like it as a PDF or
The
a?
PDF would be fine. Yeah.
All right.
And also, just for your information, the entire session will be uploaded to our SIG HPC Education a YouTube channel as well.
Perfect.
That'll happen later today. Can you comment on what your users are seeing with regard to cloud costs compared to the cost of maintaining computer resources locally?
So we, so in terms of, I don't have it, so we are not planning to replace any of our bricks and mortar data center with Magic Castle anytime soon. So in terms of compute resources locally, like I wouldn't be able to comment on what it costs locally. I don't have a view on what it costs currently. As I said, I'm essentially a developer, but in terms of what it costs to actually run a workshop with Magic Castle, it's very it's almost insignificant in terms of our budget for training. So we don't even have to ask people to actually pay for subscribing to our workshops to cover the cloud costs that are being incurred by our cloud Magic Castle usage. Just to give you an example, we during Supercomputing 23, we actually use Magic Castle to teach people about Magic Castle. So it's a bit of an inception, but we had people actually log into Magic Castle to create their own Magic Castle cluster during a 3-hour workshop. And I think at the end of that, and so we had 20% in prison that created their own Magic Castle cluster for the old workshop. And I think it cost us like 20 or $50 for the 3 hours. And so we had like around 25 Magic Castle created at the same time with people playing with all sort of different instances. So if we had only one cluster, we were talking maybe about $10 to $20 at most. And sometimes it's even less based on what the actual workshop is about. So if we are just teaching about Unix command line, a single login node is very not expensive. We're talking about a few dollars for the old tutorial. I'm not sure it fully answered your questions, but yeah,
Yeah,
it's the best I can answer it.
Yeah. Other questions? All right, well, if not, let me just put in a plug here for those of you who aren't members of SIG HPC Education chapter. We encourage you to join. It's only $10 a year, and you can go to sighpceducation.acm.org to find the membership. And that way we can get you to be informed of these kinds of talks throughout the year, as well as our other activities. And I'd like to then thank Felix for your presentation. This is a very interesting set of tools. And I think a number of people have already said in the chat that they found the talk very interesting. So thank you again. And thank everyone for joining today, and everyone have a good rest of the day.
Thanks a lot for having me.